Guys, this is lesson 5, reference angles and evaluating. So to start, here we have a unit circle. So remember what's special about the unit circle? Our radius is equal to 1. So A says label the initial side. The initial side where we start, remember, is the positive side of the x-axis. So there is our initial side. The next question, in which direction do you rotate to form an angle of rotation? The angle of rotation, remember, is counterclockwise. We start on the initial side. We rotate around counterclockwise. We can stop anywhere. We've been stopping in the first quadrant lately. Wherever you stop, remember that is called your terminal side. Part C, fill in the coordinates of each point where the unit circle intersects each axis. So if you remember, the unit circle is centered at the origin. And I said up above that the radius is 1. So that means over here on the right side, we call this 0 degrees because it's before we rotate anywhere. Your initial side also happens to be the terminal side if you don't move. The coordinates of that point would be 1, 0. The radius is 1, so that means this length right here is 1. So that's why the x coordinate is 1, because you're going to the right 1 to get to this point, but you're not going up or down at all, so the y coordinate is 0. Up at the top, if I rotate up to the top here, and I terminate, if that's my terminal side, pointing up right there, that would be an angle of 90 degrees coming off of the initial side because it's forming a right angle. And the point that would fall up there would be the point 0, 1. You're not going left or right at all, so the x coordinate is 0. You're going up 1 because, again, the radius is 1. Over here on the left, if we were to start on the initial side, rotate counterclockwise to get to the terminal side over here, we are forming an angle of 180 degrees with the initial side. And that point would be the point -1, 0. If I continue rotating, coming off the initial side, rotate counterclockwise down to the bottom, that would be an angle of 270 degrees. And the coordinates of that point would be 0, -1. And then if you were to start on the initial side, rotate all the way around and stop where you started. We also say that over at the 0 is also an angle of 360. So now we can use this here. It says question 2, using the unit circle above, find the following. Cosine of 90 degrees. Now, because this is a unit circle, remember that means that your points x, y are cosine, sine. So if I want cosine of 90 degrees, I'm going to go to the 90 degree angle up at the top. Cosine is the x coordinate. So up at the top at the 90, that point that is up there is the point 0, 1. So the x is the cosine of 90, and the y there would be the sine of 90. So since I want cosine of 90, I should get 0 as an answer. If I want b sine of 360, I'm going to go to the 360 degree angle. Sine is the y coordinate. So looking at that point that's there, the y coordinate at the angle 360 also happens to be 0. For C, to get tangent of 180, since tangent is not the x or the y, instead we can put them together. We know that tangent is sine divided by cosine. So since I want tangent of 180, we're going to do sine of 180 divided by cosine 180. So going over to the angle 180, sine on top, remember that is your y, so that is 0. Cosine on the bottom, remember cosine is your x, so that would be the -1. And 0 divided by -1 is 0. So they all happen to come out to be 0. That is a coincidence. For example, if I asked you to find me sine of 270 degrees, 270 down at the bottom, sine is the y, which is -1. So just a coincidence that those three all came out to be 0. Now we have here the definition of a reference angle, so you can pause the video and copy it down if you want. The definition of what we're going to find is called a reference angle. It is the positive acute angle that is formed by the x-axis and the terminal side of the given angle. So 2 things to point out. 1, it has to be positive. And 2, your reference angle has to be an acute angle, which we should remember means that it is less than 90 degrees. Now, the other key things, this angle is formed between your x-axis and your terminal side. So we'll see what all this means for question 3 here. It says sketch an angle of 100 degrees and its terminal ray in standard position on the axes below. So first we have to figure out where would this angle of 100 degrees fall? Which quadrant does that put us in? Well, from up above, if you remember, here is your initial side, which I said is over at 0 degrees. This is before you start rotating. Rotating, we go counterclockwise. So we're going to go up and start swinging around counterclockwise. Up at the top, we said that would be 90 degrees. Over on the left is 180 degrees. Down on the bottom is 270. And when we come swing back around again and land where we started, we've done a full 360 turn. So an angle of 100 degrees, we should see would fall over here in the second quadrant because 100 degrees is between 90 and 180. So my terminal side is somewhere over here. This is your terminal ray. Over here is our angle of 100 degrees that we just rotated around. So A here is asking us to find the reference angle. So looking back at the definition above, the reference angle has to be positive and it has to be an acute angle less than 90 degrees. And we form it between the x-axis and the terminal side. So if this here is our terminal side, and right here is my x-axis, there are 2 angles between that terminal side and the x-axis. There's the 100 degrees that we rotated around, and then there's this side over here on the left. Now, to decide between the 2, that's where the first part of the definition comes in. It's the positive acute angle, less than 90. So angle 1 over there on the left, that angle of rotation, 100 degrees is not acute. We're looking for this side over here. This side that I'm filling in and coloring in has to be less than 90 degrees. So what is the value of that angle? Well, if you take a look, these angles 1 and 2 that I have here, they together form a straight line on the x-axis. So I know that angles 1 and 2 have to equal 180. So if I want to get angle 2, I can do 180 minus that angle of rotation of 100 degrees. And that gives me angle 2, the leftover piece, is 80 degrees. So your general formula, this is going to be true every time you are in the second quadrant. If you're being asked to find a reference angle, if you take 180 degrees and subtract your angle off of it, which we'll call theta, that will give you your reference angle for the second quadrant. Question 4. Sketch an angle of 11 pi over 9 and its terminal ray in standard position on the axes below. So now we have an angle of 11 pi over 9. Well, the angles I gave you for the sides, the 0, 90, 180, 270, 360, those are all in degrees. 11 pi over 9 is in radians. So first thing that would be helpful is if we take this and convert it into degrees. So if you remember, to do a conversion, this is in radians. I want to multiply. I want radians on the bottom so that my units cancel. The degrees I want, the unit I want, degrees, goes on the top. There are 180 degrees in 1 pi radians. So simplifying this, the units of radians cancel, and your pi's happen to cancel. One is on top, one is on the bottom. So you can do 11 over 9 times 180 over 1 if you want. I would plug that right into my calculator if I were you. And you should get that 11 pi over 9 is equal to 220 degrees. So which quadrant does that put us in? 220 is between 180 and 270. So here's my initial side again. I'm going to fall my terminal side somewhere in the third quadrant now. And here is my big angle of rotation, the 220. I want to find the reference angle. Remember, the reference angle is between your terminal side and your x-axis. Now again, there are two angles that fall between there. We want the positive acute angle, the one that is less than 90, which would be the smaller one. So that would be angle 1 over here. So what is the value of that angle? Well, this angle 2 over here is not going to help me because I don't know what it is. But one thing that can help me, I do know that this big angle here is 220. Well, part of the big angle is also the angle I'm trying to find for my reference angle. Now, the top part that I don't need up here, we should know equals 180 degrees because it's forming a straight line. So I'm looking for that extra piece, this angle 1 over here. That's the extra piece of that big angle of rotation. So if I take that big angle of rotation, 220, subtract off of it the 180 that is sitting above that straight line, you get 40 degrees, the leftover piece. That is your reference angle here. So this is your formula for the third quadrant whenever you're in it. If you take your angle